Hey guys, so these are your 5.2 notes, and we're covering linear inequalities, but we're doing it with word problems this time. So very similar to what we did in 5.1, where you'll have to solve your equation into slope-intercept form, except this time it will not be an equation, it'll be an inequality. And then you'll graph it, same way as we were working on, with the y-intercept, as well as counting out the slope. And you'll also have to determine whether you want a solid line or a dotted line, and then which way you want to shade. So, hopefully you remember from what we've done previously with word problems by declaring variables, and then also trying to kind of assimilate that to what we did yesterday in class, which was, linear inequalities. So let's take a look and see what number 1 looks like. For the e-learning today, I'll do number 1 and number 2, and you'll follow along and either copy those down on this PDF if you have access to it, or you can just do it on a scrap sheet of paper. And then you'll do number 3 and 4 for homework kind of on your own, and you'll bring that in to me tomorrow to be checked. So hopefully, this video I'll try not to take more than 10 minutes or so, and then you guys can work on your own for maybe 10 minutes. So, you got to commit about 20 minutes to the class today, which shouldn't be too bad. So if I read number 1, it says, your school is holding a home game for the football team. Admission is $8 per adult and $5 per student. If your school wants to raise at least $140, then write an inequality that describes the situation and the graph. Give 2 possible combinations of tickets that need to be sold. So right away we'll notice here that when they're trying to tell us some information, we need to be able to pull information that we feel like is beneficial to us. So I can see right away that admission is $8 for an adult ticket, and it's $5 for a student ticket. So since I don't know how many adult tickets or how many student tickets are being bought for the game, I need to declare those as variables right off the bat. So what I can do is I can go just kind of in some space here and say, typically when we have 2 variables in a problem, we choose x and y. You could use like A for adult and S for student, but because we have an axis here, we know that this up here is our y-axis, and we know that this here is our x-axis. Okay, so what we'll do then is we'll just declare it. We'll say that x is going to have to equal the amount of adult tickets that were sold at the game, and y will have to equal the number of student tickets that were sold at the game. And now if I continue reading the problem, you'll notice that when we do sell these tickets, we want to raise at least $140. So think about what that means. At least 140 means 140 at the very least. So we can raise 140 or more. So 140, 141, 142, 143, these are all acceptable amounts of money that we can raise. So what we want to do, if I know that it costs $8 for every adult ticket, which I called X, but it cost $5 for every student ticket, whoops, we called student ticket Y, I'm sorry, $5 for every student ticket, I need that to be at the very least $140, which means I need these to be greater than or equal to 140. And if I add up the totals that of amount of money I sell for these two, that's my inequality. From here, you guys should pretty much be able to take off with this problem based on what we did yesterday. And so I need you guys to solve this thing for the y value so that it is in slope-intercept form. So you guys now can go ahead, go try to isolate this y value right here and get it all by itself. And so I think you guys have the skill to do that. What you would do is subtract this 8x here, but that would make you subtract the 8x here. So now these are going to cancel. And that means that a 5y should be greater than or equal to a negative 8x plus 140. And from there you can divide out your 5, which makes you divide out your 5, which makes you divide out your 5, like that, right? And if you were to continue this problem, you would see that y would be greater than or equal to a negative 8 over 5x plus 140 divided by 5 is 28, like that. And here is your equation, or it's an inequality really this time, but now it's in the slope-intercept form, which is nice because you can go through and graph it. The only thing I'd be careful on is if you start counting the scale for this grid, you know, going 28 high might be a bit of a trip up the y-axis. So maybe you think about rescaling your values, and I'm going to count these out now as well. It looks like we only have 25. So maybe we can count by twos or something just to kind of, you know, help our cause. So obviously this is 0 down here. And let's go 2, 4, 6, 8. Let's make this 10. And then let's go 10, 12, 14, 16, 18. Let's go 20 here. And then 22, 24, 26, 28, 30 here. And then that should be plenty, right? Because now I can graph 28. Otherwise, if you count 28, you might, you know, end up counting off forever. So we'll go by twos. So now what I can do is I can graph my y-intercept, which we know the y-intercept is always this number here. So if I plot a dot at 28, that's going to be just right here, right? We're just under 30. And then I'll have to find the slope, which is here, right? So my slope is this value here, which means I have to rise down 8 and then run 5. Just remember, you are counting by twos, so when you do your rise and run, be careful that you're, you know, rising and running appropriately. So let me get on this graph a little bit so I can rise and run. That's going to be a rise of 8 is 2, 4, 6, 8 down, and now 5 over. So 2, 4, and then I guess it's just like a little half. This is my dot right here. And then of course I can go again, so I'll go down 2, 4, 6, 8, now over 2, 4, and then a little half. So this is my next dot here. And I'll go one more time, down 2, 4, 6, 8, and then over 2, 4, 5. Here would be the next dot. And so that's a pretty good opportunity for you to draw an actual line that would be accurate right here. And again, you can kind of see what your graph looks like. Now don't forget, you're not done yet because these are inequalities. So my first question would be, should I have done a solid line or should I dot it? But if you look back at my inequality, you'll notice that I'm just fine right where I am, right? Because if I look at this inequality here, do you guys see this line underneath the inequality? That means I should create a nice solid line as opposed to dotting. There is something else we have not done yet, and that is to look at our shading. And for my shading, I have to look at this inequality itself right here. I have to read that out loud. And if it says y is greater than the inequality, I should shade above. If it says y is less than, I should shade below. So in this case, as I look at my inequality, it says y is greater than. So I should actually be shading above, which means I can grab some sort of shading tool. And just use a highlighter, I suppose. And I should be shading everything on this side of the line, right? And so now what I need you guys to do is go answer the actual question, which says, you know, once you're done graphing and representing the situation as an inequality, it says, can you find 2 possible combinations of tickets that can be sold? Oops, sorry about that. And all they're really asking you guys is if you can name 2 solutions to this problem. Now remember, we talked about how to name solutions. Anything that satisfies the equation or inequality is a solution. So if I pick anything in this entire shaded region here, any dot in this entire shaded region, it is in fact a solution to this problem. So I'm literally going to randomly pick, let's see, I'll go, let's just do this dot right here. It's a nice easy one. Let's see where that's at. So 2, 4, 6, 8, here's 10, 12, 14, 16, 18, here's 20. So the dot I picked is at 18, comma 30. You guys see that? At 18, comma 30. So that's a solution right there. And in that solution, if it's 18, comma 30, remember, x was your adults. Don't forget that right here. Y was your students. which means 18 comma 30. If I could write down this as a solution, that means one of your answers for this problem is where you sold 18. Let me get my pen back real quick. You sold 18 X values, so that's adult tickets, and you sold 30 student tickets. Right, so that's one scenario where you would get at least $140. Let's pick another one. So 18, 20, 22, 24, 26, 28, 30. Let's do that. 30 for X, and I'll just go up to, we'll stop like here. So 30, 32, 34, 36, 38, 40. So I'm going to pick this dot as well. Remember, anything in that shaded region would satisfy this the inequality. So that is 30 adult tickets with 40 student. And again, I just chose those at random, right? So that's kind of one example on how you could sort this problem out. Let's take a look at number 2, and then like I said, I'm going to have you guys do 3 and 4 on your own as practice. Number 2 said, it's your friend's birthday, and you want to get her balloons. A large balloon is $10 each, and a solid color is $2 each. You cannot spend more than $50. Write an inequality that describes the situation, and then give 2 possible combinations of balloons you could buy. So again, you're seeing kind of a pattern here. You're given loads of information, so you need to pull some information out, right? And the first thing you'll notice is that it tells you a large balloon is worth $10, and a solid color is worth $2. So right away, hopefully you know what to do at this point. You're going to make your X value equal to the cost of a large balloon. And you're going to make your Y value equal to the cost of a colored balloon. So if that's the case, you know that if I spend $10 on each large balloon, and I add up the cost of $2 for each colored balloon, it says I cannot spend more than $50, right? You cannot spend more than $50. So what can you spend? You can spend 49, 48. You could actually spend 50 if you want. You just can't spend more than that. So 49, 48, 47, which means for this inequality, this amount of money right here needs to be less than or equal to $50, right? Because you cannot spend more. So then the equation you're solving, or the inequality really, has to be less than or equal to $50. So there's your setup there. The next thing you want to do is just solve this inequality. Again, like we talked about before, you're going to solve this inequality by trying to isolate this Y value right here. So if you look to isolate that Y value, what you're going to see happens is you're going to have to, again, subtract that 10x out on this side, but that's going to make you subtract it on this side. So this 10x and this negative 10x will cancel each other. That means that a 2y value will now be less than or equal to a negative 10x plus a 50. So if I try to continue to get that y value alone, I would divide out 2, I would divide out 2, and I would divide out 2, which means that y is now going to be less than or equal to, simplify here, that's a negative 5x all plus a 25. So again, we know this up here is my y-axis. We know that this down here is my x-axis. Oh, sorry, it's at the bottom of the screen, so it's having a hard time writing. And so again, you guys can start getting after this problem as well, knowing that as you start to graph it, you will have to be conscious about like the values you pick. This one, it looks like I have enough to count one for one because I believe there's 25. Let's see, if I go 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yep, you'll just make it. 21, 22, 23, 24. There you go. 25. And you can do the same on this side if you want as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That should be plenty, just because you're going to rise and run anyways, and your run is only 1, so you can just go that far if you'd like. So let's graph. So I got to get my y-intercept on the graph, which we know the y-intercept is always this value here, right? So let's get a nice good dot at 25 on the y-intercept. Come on. Now I will just be careful here. I would suggest, since your slope is here, which is -5, I would call your slope a -5 over 1. That way you'll know how much to rise and you'll know how much to run. Like that, right? So I'm going to rise -5 and run 1. And I'm just going to get in, closely so we can see exactly what that looks like. So I will rise -5, run 1. So rise 1, 2, 3, 4, 5, run 1. So here's my first dot. Rise 1, 2, 3, 4, 5, run 1. Here's my second dot. Rise 1, 2, 3, 4, 5, run 1. Here's my third dot. And we just keep going with this, right? Rise 1, 2, 3, 4, 5, run 1. And last time, 1, 2, 3, 4, 5, run 1. Alright, that should be plenty there. I do need to check if this is solid or dotted, so I'll look at this sign right here. Right? Notice it says y is less than. So because y is less than, after I draw this line in here, and it's hard to draw on the iPad, so this may not be the best straight line you've ever seen. So you're going to take this line right here, right? And you're going to have to shade underneath the line because it's less than, right? So grab some sort of shading utensil, and you're just going to shade under the line here, right? And then don't forget, they also asked you provide 2 solutions to this inequality. Well, 2 solutions to this inequality are any dots that are inside the shaded area. Because when we shade, what we're actually doing effectively is we are like noting all the solutions, every dot, every coordinate, every ordered pair that would solve this. So I'll just pick some super simple ones. Let's do like this dot, for example, right here, which is at 1, 2. Remember, this is your x value, this is your y value, which means if I pick 1, 2, don't forget, x was large balloons and y was colored. So when I say 1, 2, I'm really saying you could buy 1 large balloon and 2 colored, and you would spend less than $50. Try to find another answer. Another example would be if I chose this dot right here. 1, 2, 3, 1, 2, 3, 4. I'm just gonna do this one right here. That'd be another good example. That's at 3, 3, 5, right? So what if I did 3 large balloons and 3, 5 colored? You would also solve that inequality because you would spend less than $50. Okay, so hopefully that helped. If you guys have questions, let me know. But then on the back side, this is your job. You guys need to do 3 and 4 and bring them to me. I will check them in class tomorrow. Okay, have a good day. See you guys.